Okay, we're going to look at multiplying a vector by a scalar. So here's our vector. You can almost think of it back to like basic algebra. There's technically a scalar involved with this vector, and the scalar is the value of 1. Okay? Why do they say a scalar value of 1? Because if I multiply 1 by anything, it keeps it the same, right? So though it's not written, you can make the assumption that there's a scalar of 1 in front of any vector that is written. I think that's called identity property. But what do scalars do? Scalars are just some multiplication of that vector. So be aware that vectors have to have direction and magnitude. So this vector has a direction. It is heading, I don't know what quite that angle is, but it's heading in this direction here, and it has a magnitude. I could give it any magnitude, right? I could say it's a distance, it's a speed. Let's say it's 5 kilometers an hour in this direction, sure. So it's heading this way. If I wanted to give a scalar of this vector, let's say I looked for 2v. That's simply just taking this vector and putting it end to end with the identical vector. So this now represents from this starting point to here, this now represents the scalar 2v, okay, which is exactly twice the same direction, but twice the magnitude and direction of the original vector here. You can use negative scalars also. A negative scalar, if I were to say negative 3v, this one will be a little harder for me to duplicate, so I'm going to have to spin this. But if we do this, and, see, I don't know if I'm going to get the same distance. Let's say for, got it built right? No, it's probably not it. Actually, I got it pretty well drawn in these boxes here, so there you go. So you'll notice this is now going the opposite direction. So a negative just means the opposite direction it was originally going. And now that I have one of them, I need to obviously multiply by the value of 3 here. So let's clone it once, not once, but twice here, and have 3 of them back to back. Clone again.
Or so just go 3 times down.
Yeah, that's it. So now this is the new direction, which is the opposite of the original direction. So think of it like we start here, and this is the direction that it's heading, and it is 3 times the magnitude of the original vector we had. So again, remember that's that concept of this is the value of 1. Well, 2 would be twice that distance. Negative 3 would be the opposite distance, but 3 times it in this case, okay? Other rules you can use to apply this, if you're ever adding vectors, so say, and this is a little more theoretical, let's say we have vector v plus vector, I don't know, what letters do they use here? U, that's a good letter. Vector v plus vector u, and we're going to multiply by some scalar. We'll call this scalar k. You can use distributive property to multiply these out. This is the equivalent of saying scalar k times vector v plus scalar k times vector u. That's just a simple distributive property, same algebraic rule. Along with that, you can use an associative property rule. Let's say I have 2 scalars times a vector. We'll call it scalar s and scalar k are being multiplied by vector v, okay? And these scalars essentially represent any number, right? I can do this in any order, do the associative property, so I could set this up so that it is s times k first, then times vector v. I can set this up so it is s, but it's actually k times vector v first. This is still the same thing. I could set it up so that it is k s vector v. Any other options? No, I think I got them all, right? Yeah, all of these are essentially equivalent due to a rule in multiplication called the associative property. I think that kind of covers everything there is to do with multiplying scalars by vectors. We got opposite directions, distributive property, identity, and associative property. Yeah, that's about all of them.